Okay, rotations and symmetry. There's a lot of notes here, guys, and not a lot of samples. Unfortunately, this is something that's hard for some people to see, so it's just going to be a lot of practice time in class on this one. But rotations is it's a transformation in where you take a figure and you turn it. You pretend you imagine it being on a clock, like a number on the clock, and the minute hand grabs it and then rotates that number around to a different location. So it's turned about a fixed point. That's called the center rotation. For our class, the center rotation is only going to be the origin. The angle of rotation is formed by rays drawn from the center rotation through the corresponding points of the original and its image. That's a little confusing, but the idea is that if you look up here at the sample, here we have from the origin a line that points to this point on the star. If you rotate 120 degrees and then you draw another line, it goes to the exact same point on the star. So if you went, for example, to this point, and then you rotated 120 degrees, you come out and it goes to that point. So each point is rotated the same amount from that center of rotation. Okay, we can rotate clockwise, counterclockwise, but the figure and its image are always congruent. All right, in order to do 90 degree, now what we're doing for our class to make things a little bit easier on you, we are only focusing on 90 degree rotations and 180 degree rotations. So a 90 degree rotation could be clockwise or counterclockwise, and the easiest thing to do is to show you what the coordinate notation would be for each one of these. If it's a 90 degrees clockwise rotation, what you do is you switch the coordinates and multiply the new y by a -1. Or you could just say xy becomes y and then the opposite of x. You put them in that order. To do a counterclockwise rotation, xy becomes -y and then x. Or you could say switch the coordinates and multiply the new x coordinate by -1. For a 180 degree rotation, I don't mention here clockwise or counterclockwise because it doesn't matter. You end up in the exact same spot. So to do 180 degree rotation, here you take the opposite of both the x and the y values. So again, you take whatever the x is, you do the opposite, whatever the y is, do the opposite, and you can end up with a figure that is rotated 180 degrees. All right, rotational symmetry. An object has rotational symmetry if 180 degree or less rotation about its center produces an image that fits exactly over the original. So here, what we have is the original figure, and then we have a 90 degree rotation. You notice that when it's turned, it still looks like the original figure. It doesn't matter which way it was turned, and you could also turn 180 degrees and it still looks like the exact same figure. That's what rotational symmetry is. Okay? We'll get a lot of practice time on this in class, I promise.